NVMe PCIe Gen4 SSD offer very high performance and low latency on single SSD device, making it possible to share the single SSD with multiple users at the same time. Today, we would like to introduce the new data storage IP core, which can allow multiple data stream access simultaneously to NVMe PCIe Gen4 SSD, utilizing the latest NVMe SSD more efficiently and maximizing system's performance. Introducing the muNVMe-IP core for PCIe Gen4. This video will show you 4 topics. Let's start with NVMe SSD performance versus PCI Express speed comparison. Maximum data bandwidth is double over each PCI Express generation. NVMe SSD uses 4 PCI Express lane, which mean a theoretical maximum speed for each generation are 2 GB per second for Gen 2, 4 GB per second for Gen 3, and 8 GB per second for Gen 4. From our test with high-performance NVMe SSD model, we found that practical SSD performance is around 75% as shown in this chart. Anyway, 6 GB per second performance from NVMe Gen4 SSD is very high and possible for sharing access among multiple users. Let's see data rate requirements in some high-end application. In 8K RAW video stream, 8K resolution with 24-bit color and 30 frame per second, need to handle date rate around 2848 MB per second. In 4K RAW video stream, 4K resolution with 24-bit color and 60 frame per second, need to handle date rate around 1424 MB per second. One of the example application is 8K Ultra HD video recording at 120 frames per second. This application requires about 2800 MB per second at a sustained data rate, which can be implemented based on our NVMe-IP core DDR reference design. One of the example application is 4K Ultra HD video recording at 120 frames per second. This application requires about 1400 MB per second at a sustained data rate, which can be implemented based on our NVMe-IP core DDR reference design. In 5G wideband receiver, or 5G radio data logger, with 10 GB sampling per second, need to handle date rate around 1250 MB per second per 5G radio channel. In high-end 640 slice CT scanner, has the capability to scan 1000 times more images per second than traditional CT scanner, need to handle data rate around 1800 MB per second or more. Above example requires 1 to 3 GB per second data rate per direction, which still have room utilize remaining bandwidth for multiple access. Next, let me introduce you the muNVMe-IP, or multi-user NVMe-IP core. Comparing with standard NVMe-IP core, which is designed to operate with single user only. NVMe-IP core can execute only one command from one user at a time, while muNVMe-IP core is designed to support up to 4 users and can execute command from each user simultaneously. Both IP can be configured with 2 different buffer modes. 1 MB buffer size for high speed and high performance application. 256 KB buffer size for normal application. Here is system's overview of muNVMe-IP core. Support up to 4 users interface, and able to execute each user command simultaneously. Each user can send read or write command at time. First user can support 6 commands included with 4 SSD management command identify, shutdown, smart, flush, and to transfer command read and write. The IP is designed to interface directly with PCIe Gen4 hard IP in root complex mode. Internal buffer size can be configured in 2 modes: 1 MB size and 256 KB size. Next, let's see possible application for muNVMe-IP for NVMe Gen4 SSD. First example application, multiple 8K and 4K video stream recording. NVMe Gen4 SSD is capable to record 1x8K video stream and 2x4K video stream at the same time. Each video stream can directly interface with each user interface of muNVMe-IP, allowing to create multiple video channel recording systems without no CPU and OS. Second example application is 5G radio data logger. Each 5G radio channel is captured at 10 GB sampling per second, which is around 1250 MB per second. Multiple 5G radio channel recording at the same time is possible by muNVMe-IP core. and high-performance NVMe PCIe Gen4 SSD. While real-time recording, you can use available user interface to read recorded data from SSD for monitoring or radio data processing without need to stop the recording systems. The last example application is high-performance CT scanner for medical application. For 640-slice CT scanner, raw data rate from CT scanner is around 1,800 MB per second. For more advanced and higher performance such as 1,024 slice capable, raw data rate may be around 2,900 MB per second. High performance recording speed up to 3,000 MB per second, while simultaneous read for data analytics should enable highly efficient CT scanner operate and usage to server as much as possible patient. Hope these 3 example applications could show you the possible use cases and potential of muNVMe-IP core. To learn more, please check out the next video part 2 for the demo and performance result on real board. You can also check our NVMe-IP core with DDR reference design for sustained data rate application implementation. So if you are interested in our IP, you can check it out in our website design-gateway.com. Or just click the link in the description below. Thank you. See you in the next video.